we are on time. Yes, we are live now. So, yeah, welcome to our live stream. We are in day 15 of 150 days, right? A DSA journey. So, everyone who is watching this live stream right now, or just watching this afterwards, one second, okay, here we are in day 15. I think today's problem will be here. Yesterday we solved gas station, right? Let me just remove all this. Now, today we're gonna solve the current problem. This is today's problem, right? You know, uh, let us just read the problem once. First of all, yeah. So the question name is pretty simple. Candy, right? One second. Okay. So there are n children standing in a line. Okay. There are n children standing in a line. Each child is assigned a rating value given in the array ratings. So we are also given ratings. These are having some, a good marks. It can be good marks in an exam, or they just uh, they just came in time to college, whatever school. They are children, right? So yeah, so the ratings are here. Ratings can be whatever. We are just given some ratings, right? So this is an array, just like that. This is an array. Now we are given these ratings. Okay, you're giving candies to these children subjected to the following requirements. Each child must have at least one candy, right? One candy is at least. Every child gets at least one candy. Children with a higher rating get more candies than their neighbors. High rating is equal to more candies, more candies than neighbors. Let me tell you, have been, this is just like I just want to share something. If most of the households, right, they just follow these type of models, right? I don't know why LeetCode also gave us, you know, people have this tendency that if you get high marks, you are the best in school. The same with CGPA in college, you are the best in college than your neighbors. You just you just keep this thing in everywhere, right? You just compare anyone, right? You just compare them with anyone you see here than their neighbors. Even in LeetCode, we are just seeing this comparison, right? It's just it hurts for the children who are receiving these candies, right? So I don't know what are these ratings, but our job is not to change the problem. We just have to just solve the problem, right? So, and I am pretty thankful that they are at least giving one candy to children, right? So we need to return minimum number of candies you need to have to distribute the candies to the children. Okay, we are given with the constraints 5 into 1 is 4, 5 into 1 is 4 for the size of n, sorry, yeah, ratings and ratings of I. Now, if you see, there are some ratings. One second here. 102. We are given with some example. Ratings is 102. Let me tell you this as something which I say. This is just pretty easy, right? So here he got 0. So let me give him only one candy. But I won't do like this, right? Now he is having 1, so he'll get 2, right? Now here we are having 2 which is greater than the neighbor, so he'll get greater than the candies which the neighbor received, which is nothing but 2, right? So the total will be 5. Now let's take another example. Here the ratings is 122. Ratings is 122. Now here comes the actual observation, right? So children with a higher rating get more candies than their neighbors. With higher rating, it doesn't mean equal rating. With higher rating, they just receive more candies. If you see, he gets one candy, but when you go forward, here it is 2 as a rating, which is greater than the neighbor, so he'll just get 2 candies more than the previous one, because he has higher rating, right? Just like marks. And here he or she, whoever, 1. Why? Because you might say here, bro, here we have 2, here we have 2, it doesn't matter, only higher. If the current candidate or current child is having higher rating than his neighbors, then only he'll just have more candies than the other, right? So I think it makes sense. Just like um, how our society just just let's don't talk about it. Let's just solve the problem, right? So yeah, first thing, yeah, Hari Subramaniam, bro. Thank you for attending the live session, right? So first, bro, which language is best? I mean, currently I'm learning Java. So if you're learning Java and you're in mid, so you just can go with that. It doesn't matter. Of course, Java and Python is best, but Java and Python, you can just go with even the development. And people aren't looking. Recruiters don't look at your language. You you just have to say, you need to communicate well. That's the first thing, and you just need to have clear understanding of problem solving, right? It doesn't matter you code in Java or Python or C++, right? It's just the algorithm will be the same, just the syntax will be different, right? So I think your dot is clear. Hari Subramanian, Hari Subramaniam, right? Yeah, let's go to the problem. um, you know what I'll do, I'll just take a random example, 1 double 2, so let's take 3, 1 and then 10, a 2 here, 1, 5 and then 6. You know what we'll do, we just have to go with we just think that we need to go with the algorithm. You just don't think about the algorithm when you see any problem, you just look at this one. Okay, okay, first thing, they said at least one candy for each child. So what I'll do, I'll just give one candy for every child. So I'm just taking this as ratings array, I'm just giving one candy for every child. Right? Now, if you see, I have one, so only neighbor I have is two, right? But I don't care. Now I have two here. I'm looking at the left. I'm just looking at the left, right? So if I compare ratings of I is greater than ratings of I minus 1. I think you got it, right? So at this moment of time, what I'll do is I'll just take this, and the current one, the ratings of I is, greater than the neighbor, the greater than the left one. So what I'll do, I'll just keep it something like, I'll just increment it, right? Now let us go here 3. I'm just looking at the left one, right? I'm not looking at the right one for now, right? So if you see, 3 is greater than 2. It's nothing but this child should get much, just even if it is just one more candy he should get. And why I'm just adding only one? Why cannot I just have 3 or 4 or just 100 here? Because we are asked with minimum. You can look here. You can look here. We are asked with minimum number of candies you need. We just didn't ask for 100 or 200 candies. Now we are at 3, which is greater than the left rating. This kid, this child is performing well. Thank you, bro, but your voice is too low, not audible, bro. Now it's working. Yeah, is it working now? I think so. Hari Subramanyam. Right, so I have 3 here, which is greater than the left one. I'm just looking at the left child. This child is having much greater rating than the left one. So what I'll do, the left child is getting 2 as the rating. Now the current child should get greater than 2, so it should be 3, right? Now here we are at 1. Here comes the actual question. Is 1 greater than 3? Absolutely no. So it's just 1 there. Now 10. Is it greater than 1? Yes, but let me tell you one thing. A bigger rating doesn't mean it should get candies equal to the rating. It just need to get candies more than neighbor, right? So that's, I think you got it why we are just looking at the left, right? Yeah. So just 2 here. Now we have we are moving forward. We just go to 2, and you can see 2 is not greater than 10, right? So we don't change anything. Now is 1 greater than 2? No. 5? Yes, it is greater than 1, so it should get more candies than the neighbor, so I'll just increment it. Right, now we have 6, which is greater than 5, so do the same thing here, right? Okay, one second, I'm just okay. Now you know I have an error here. I cannot return like this. Why? Because this is having a rating of 2, but the neighbor is having a less rating, so this should get much more than the neighbor. So what we'll do, we'll just, here we went here we went from left to right. Bro, could you teach in Telugu? uh That's I've been teaching in English, bro. Yeah, I can understand, but I've been teaching in English from since I started this YouTube channel, right? Sorry that I'll get a way so that you can understand, right? So I am going from left to right, okay? So I looked at the previous one. Now let me go from right to left and I look at the right one. So here, is 5 greater than 6? No. Is 1 greater than 6? No. Is 2 greater than 1? Yes. So what I'll do, I'll just change it to 2. Now is 10 greater than 2? No. Yes, sorry. Yes, right? So what it should have is 3. Now is 1 greater than 10? No. Is 3 greater than 1? Yes, right? But let me tell you one thing. If you see, I already have a 3 here, which is greater than the rating I have, right? So do I have to change it to 4? No. I'm just incrementing, I'm just giving candies which are not needed. Why? Because this 3, this 3 already greater than the right neighbor and also the left neighbor, right? So I think I don't have to. But how do I just skip this? So when I am uh, changing I'm changing answer, or let us just take count of I will be max of count of I comma ratings of I plus 1 plus 1. I think you got it. The maximum I got here, and 1 plus 1, which is 2, right? From those two, the maximum will be 3, so I don't change it, right? So yeah, count of I is max like this. But how do I check this? Is is if ratings of I is greater than ratings of I plus 1. I'm writing the same thing. Ratings of I is greater than ratings of I plus 1, right? Then I'll just change the count as max of count of I comma ratings of I plus 1. Sorry, so I just overlooked. It should be count of I plus 1 plus 1, right? So I'm just looking for the ratings, but I'll start here. Why? Because then only I can look at the right. So what is this? It is n minus 2, it is n minus 1. Here it is 0, 1, 2, something like that. So I'll start with for I is equal to n minus 2, I is greater than or equal to 0, I minus minus. This will be done, but let me tell you, for before going from right to left, I need to go from left to right. So for I is equal to 1, I is less than n, I plus plus, if ratings of I is greater than ratings of I minus 1, then I need to just change it as count of I is equal to count of I minus 1 plus 1, and we'll just return the sum. Return, let's just say sum is equal to accumulate. uh, I think we just don't need to do this. I think we can have sum is equal to 0, sum plus is equal to count of I. Here we'll just change again, sum plus is equal to count of n minus 1. Sum plus is equal to count of n minus 1 and return the sum at the end. That's it. That's how we solve this, and we'll just initialize vector of int count here. I think that's it. Yeah, let us just do the code part here. So first let's take int n is equal to ratings dot size. Now vector of int count, where I'll have the size of n and everything will be initialized with 1. For int I is equal to 1, I is less than n I plus if ratings of I is greater than ratings of I minus 1, then count of I is equal to count of I minus 1 plus 1. Now count of I, why I'm getting like this? Okay, it's okay. And sum is equal to 0. Now for int I is equal to n minus 2, I is greater than or equal to 0, I minus. If ratings of I is greater than ratings of I plus 1, then uh sorry, then count of I is equal to max of count of I, and count of I plus 1 plus 1, and sum plus is equal to count of I, and sum plus is equal to count of n minus 1, return the sum at the end. I think this should work. No, it didn't. Ratings of I is greater than ratings of I plus 1. Okay, runtime n minus 2. It should be n minus 2. That's my fault. Okay, output for expected 5. Count of I minus 1 plus 1. Can we just take this out instead of there? It doesn't make any change, but for int I is to the rise and I plus plus. Yeah, I think there is an error, but why did I get like, let me submit it, but why did I get yeah, here uh I'm including this count of I sum. What I did, the what error I made, mistake I made, is sum plus is equal to count of I. So only if ratings of I is greater than ratings of I plus 1, then only will add to the sum. So it's not right. So sum plus is equal to count of n minus 1. Now it will work definitely. Yeah, so we are just submitting our code, and here we are. And what is the time complexity which we are using here? Big of n plus big of n will be big of 2n, which is not exponential, right? So I think that's it. And so yeah, if you have any doubts, please let me know. And thanks, Hari Subramaniam. Thanks for attending our live session. Alright. So this is a hard problem, but I think only hardest part here is just figuring out. It just need two iterations, two pass, just like that. I think I think we just solved this in just 20 minutes. Let me tell you, I'm just you know, it's not that I'm bored. I just did good. Okay, 1016. Okay, okay.